We're talking about the adrenal glands last time. The adrenal glands look like a glob of fat. I told you this last time. They look like a glob of fat on top of the of kidneys. Kidneys are a really dark color. They're almost black. They're so dark. Yeah, they're really dark. So is your liver is pretty dark as well. They're a brownish reddish color. It's really kind of odd. Some people eat these things, and not human kidneys, of course, but they eat kidneys. Personally, I think they taste like urine, but because that's their job is to make urine. But some people eat them and they love them because I don't know why they love them. I have no idea. Anyway, the adrenal glands are on top, and normally you don't eat the adrenal glands. They end up in sausage or hot dogs or something. What are we talking about? Okay, like the pituitary gland, the adrenal glands are divided into two portions. The adrenal cortex, which sounds like it's in the middle, but it's actually on the outside. Cortex in this case means bark. And the adrenal medulla, in that case, medulla means middle. So you've got you got two different parts, and they're completely alien to one another. One is in the middle of the adrenal gland, and the other is on the outside of the adrenal gland. As much fun as that is. Adrenal medulla releases the amine hormones, epinephrine and norepinephrine, in response to the sympathetic nervous system. We talked about this last time. Adrenal cortex produces and secretes some of the steroid hormones, the adrenal corticoids. It also releases glucocorticoids, which affects your metabolism, the metabolism of carbohydrates. Cortisol is a good example of a glucocorticoid. And cortisol has a very important function. It is released when you are it's released by your sympathetic nervous system when you're under stress. But cortisol also, cortisol's a funny hormone. We have an automatic release of cortisol at 8 o'clock in the morning and 4 o'clock in the afternoon. It's the oddest thing. So no matter how much stress you're under, you're going to be releasing more cortisol at 8 o'clock in the morning and 4 o'clock in the afternoon. Now they try to figure out why in the world at 8 o'clock and why in the world 4 o'clock in the afternoon. Well, usually at 8 o'clock in the morning, it's time to get up. And it's also time to get going. And so you will have this surge of, and everybody has it. It's the most bizarre thing in the world. If you're human, you have a release of cortisol at 8 o'clock in the morning and 4 o'clock in the afternoon. Of course, 4 o'clock in the afternoon, it's time to look for someplace to sleep, to stay away from the predators and stuff. That's what they assume that it's all about anyway, and that's cortisol. Second group of adrenal steroids is the mineral corticoids. They affect the ion concentration of sodium in the kidneys. Really, really important stuff. Aldosterone acts on the kidneys to reduce urine output and conserve sodium. Thus, it also conserves water at the same time. And this is one of the reasons, and this is one of the functions of the adrenal gland, is to tell the kidneys how much fluid to save or not save. Okay. The adrenal cortex also produces the sex steroids. The chief sex steroid produced by the adrenal cortex is androstenedione. This is, Mark McGuire got caught with this stuff in his locker back when he was hitting home runs for the St. Louis Cardinals, breaking the Major League home run record. And they realized at that point that he'd been using steroids all along. Mark McGuire holds the record. Judge, Aaron Judge, is about to break his rookie home run record, but Mark McGuire holds the record. He's always been a big fella, and one of the reasons may be because he's always been on steroids. Androstenedione contributes to adult hair growth patterns in men and women, and for this reason, if you take this stuff, and one of the things that happens to people that take steroids is that they lose their hair. They go bald. They also get a lot of pimples, which is kind of fun. Usually it's in odd places like on their backs. They have pimply backs.
Back knee.
Back knee, exactly. So if you've ever been around anybody that uses steroids, they've got it's nasty. It's really nasty. I mean, pustules all over their back. It's really kind of bizarre. So if women take this stuff, they get a male hair pattern. Sometimes they lose their hair on top of their head. They'll grow facial hair, which is always attractive on women. They'll grow chest hair, which is always attractive in women as well. And they'll grow a male pattern of pubic hair, which is always fascinating to anyone looking at some of these umbilicus. Males can grow, not all males of course, it all depends on your genetic structure, but some males will grow pubic hair all the way up to their umbilicus. Especially really hairy guys will do that. People from, I don't know, wherever. People that grow really heavy really heavy beards will have different hair growth patterns. Just very fascinating, really fascinating. I played ball with a guy from Italy, or not from Italy, his name was Macucci. Vinny Macucci, he was our shortstop. Really good ball player, but hairiest guy I've ever seen. The guy looked like a bear. I mean, it's the oddest thing in the world. He went swimming. This is a guy that had to shave not only his neck and his chin, but he also had to shave all the way down, halfway down to his chest. Just the oddest thing in the world. And then he'd have this massive hair coming out. At the swimming pool, he looked very, very odd, so he didn't go swimming a lot. The adrenal cortical hormones are controlled by ACTH released from the pituitary gland. However, ACTH, it just doesn't start with ACTH. It actually starts with the hypothalamus. Hypothalamus tells the pituitary gland to release ACTH by releasing corticotropin-releasing hormones. So it's the hypothalamus that tells the pituitary gland to release ACTH. Unfortunately, the glucocorticoids released because of the ACTH, when released at high levels, can kill nerve cells in the hippocampus. The hippocampus is where your memory is. So the more stress you're under, the worse your memory is going to be, because it kills cells in your hippocampus. So if you've lived a life of a great deal of stress, one of the things that will potentially happen to you is that you'll develop Alzheimer's disease because of the death of all of these nerve cells in your hippocampus. Ouch. So people who are type A personalities are more susceptible to Alzheimer's disease because of this. I know it's a tragedy, it's not my fault, I didn't have anything to do with it, but type A personalities, a lot of times this is one of the problems that they have. Okay, the thyroid gland, very, very important gland. It's the one that maintains your metabolism. It tells your body how much energy to store. And once you store the energy, of course, then you can react to stress. You can react to just about anything. But it maintains all your body parts, all the cells in your body. And that's what metabolism is all about. It's located right underneath your voice box. So if you're male, you've got an obvious voice box. It's right down below that. It's just above your neck. It's right here. It's right where my bolo tie is. It's right there. It secretes that your thyroid gland secretes three different hormones. One of them is thyroxine, T4. So if they've ever checked your thyroid, probably they checked your T4. They may have checked your T3 at the same time. Usually if there's a problem, it's thyroxine, but sometimes it is the triiodothyronine, the T3, or the calcitonin actually has to do with calcium, doesn't have to do with metabolism. So if we're worried about your metabolism, if you're really, really skinny and we think you're hyperthyroid, then we'll check your T3 and T4. We can also check your TSH, thyroid stimulating hormone, because that's produced by the pituitary gland, and it tells the thyroid how much T3 and T4 to maintain. Now the interesting thing about T3 and T4 is that you store it for an extended length of time. You've got about 100 days of thyroid in your system, or T3 and T4 in your system. So if your thyroid stops functioning, we're not going to know it for about 100 days. That's just the way it works. And you won't have any effects from it until about 100 days out. And at that point, of course, then things will start going south. The hormones are stored in your thyroid colloid. It's the mass of your thyroid. As you can see, it's butterfly shaped. It's relatively large. It goes all the way down into your chest. Fascinating. The thyroid maintains a large supply of hormones, and this is what I was saying before. Calcitonin promotes calcium use in the bones. T3 and T4 levels are regulated by TSH released by the anterior pituitary. So the pituitary gland controls the thyroid, and it tells the thyroid how much of this stuff to maintain. And normally, unless you don't have a thyroid or unless you've had problems with your thyroid, everything always works perfectly. Very few people have thyroid problems. We do have people that are hypothyroid. It means that their metabolism isn't working very fast. You know, you see skinny people and they say, well, I've got a really good metabolism. I can eat all the food I want and I never get fat. Well, that may be true, and that metabolism is, of course, is maintained by your thyroid gland. As fascinating as all that is. So what else happens? What else am I talking about? I can't remember. I was headed in a direction I can't remember what it was. Anyway, so your pituitary gland controls this. Okay, I was talking about being hypothyroid. Okay, so if you're hypothyroid, your metabolism is kind of slow. If you're hypothyroid, you possibly will gain a lot of weight, gain some weight, because your body's just not burning the fuel that it's taking in, so you gain a lot of weight. At the same time, if you've got somebody that's really, really skinny, they look like they're on crystal meth. They look like they're on speed. They look like they're burning too much of their fuel. And that's hypothyroid, or hyperthyroid, I'm sorry, hyperthyroid. There's only one thing we can do for somebody that's hyperthyroid, and that is to remove their thyroid gland and give them T3 and T4 to maintain themselves. So we take out their thyroid because it's overactive, and since it's overactive, now we're going to give them a normal amount of thyroid, and they're going to gain weight, and everything's going to be fine. If you're hypothyroid, we can give you either TSH or T3 or T4. We can do that, and that will increase your metabolism. So a lot of people say that they're hypothyroid because they've gained weight, and sometimes they're correct, but usually they're not. They just eat too much food. T3 and T4 are amines that act as steroids, passing through the cell membrane, finding a receptor in the cell, and then binding to the DNA. T3 and T4 are released from the thyroid gland because of the influence of TSH from the pituitary, which is induced to release TSH when stimulated by thyroid tropin-releasing hormones secreted by the hypothalamus. So once again, it is the hypothalamus that actually controls the pituitary gland. For the longest time, of course, we didn't realize this. We thought that the pituitary gland was the master gland, but now we know that the hypothalamus actually tells the pituitary gland what to do, which doesn't seem like, seems like the hypothalamus is the master gland. You can have a problem with your thyroid. And I just talked about being hypothyroid and hyperthyroid. If you're not taking in enough iodine, the T3 and T4 function with iodine. And if you don't have enough iodine in your system, now we got a problem. We got a really serious problem. So when humans, we think that humans evolved around the sea because we need, hi Joe, we need iodine. And where do you get iodine? You get it from the sea. There's no other places to get it. You get it from seafood. So if you eat shellfish, then you're taking in adequate iodine. You can't take in too much iodine, but you can take in not enough iodine.
How about sardines?
Any seafood has iodine in it. Okay. We didn't understand this until the 1930s, 1920s, 1930s. Before that, we had a really serious problem away from the sea. So people that lived in New York City were okay, but people that lived in Ohio and Illinois had problems because they weren't taking in enough iodine. So you have to take in iodine. An inadequate supply of iodine will lead to hypothyroidism. Since the thyroid output is inadequate, the pituitary produces more and more TSH to compensate, but only succeeds in enlarging the thyroid in a condition known as goiter. And this is what a goiter looks like. This is a really severe case of goiter. Once upon a time, practically all the kids in the United States in the middle of the country suffered from goiter, especially if they were poor kids, because they couldn't afford any kind of seafood. And of course, at that time, we weren't shipping. We didn't have any refrigeration, so there's no way to really ship seafood from one place to another. I guess canned sardines is one way to get it. So there were a lot of people that suffered from goiter. Now, of course, in the 1920s, we figured out, oh, wait a minute, all we need to do is put iodine in something, or make the kids take iodine. Well, iodine tastes really bad. It's really bitter. So what we started doing was putting it in salt. And that's one of the reasons why, if you go to the store and buy one of those tubes of salt, it's either iodized salt or non-iodized salt. Most people use the iodized salt. Well, people from the Midwest do anyway, because they need the iodine and they don't have it in their diet. Can you think of any seafood that you eat normally? I mean, do you guys have lobsters like every third day? I'm sorry?
Tuna from Subway.
Tuna would work. Tuna would be fine.
Shrimp.
Yeah, if you eat shrimp. So you're okay, don't worry about the salt. You're getting your iodine. But I can't eat that stuff. I can't eat seafood. If I eat seafood, my feet swell up. Well, I guess the question is, do I want my feet to swell up or my neck to swell up? That's the question. But I used iodized salt, recognizing the fact that this is a problem. My mother had goiter when she was a kid. She was born in 1915. They didn't figure this out until the 1920s. And of course, you know how bullheaded a lot of people are. They didn't believe, they thought that the government was trying to sterilize them or something. So they wouldn't eat the iodized salt. They wouldn't use the iodized salt. When people first started using it, they complained about it. They said it tasted bad. It had a different flavor than regular salt has. So they stopped. They didn't eat it. Until 1924, goiter was endemic in areas of the United States where iodine from seafood was not prevalent. In Michigan, in a study in 1923, they showed 39% of a prevalence rate among school children. And Michigan is right on the Great Lakes, but this isn't seafood. That's lake fish. It doesn't have any iodine. It doesn't. That's not salt. They're not saltwater fish. So of course, they can eat all the fish that they want, but they're not getting any iodine with their fish. That's in Michigan, right there on the lake. Ohio, which has their northern border is Lake Erie. In Ohio, 31% of the school children were estimated to have goiter. In West Virginia, as long as they ate the brown salt, they were okay. Why brown salt? Because iodine is brown, and if the salt is brown, it means it's got iodine in it. So if they ate the brown salt, they were okay. Then some brilliant person convinced them, oh my goodness gracious, you can't use that local salt. That's got dirt in it. You need to use fresh, white, good salt. So they replaced the brown salt with white salt, and in 1922, a study showed that 61% of the school children had enlarged thyroid glands. Sometimes good ideas turn out bad, and this is one of those cases. So the people in West Virginia were fine as long as they were using the local salt. When they started using refined salt, their kids started suffering from goiter. 61% in 1922. Anyway, I'm sorry.
I'm sorry. Isn't the Great Salt Lake has a lot of salt in it?
Yeah, sure, Utah. Yeah. That's Utah.
Is that good salt or bad salt?
Oh, it's good salt. It's this part of the country used to be under there was an ocean that ran through this part of the country. So yeah, that salt's good salt. I mean, that salt has iodine in it. It's seafood or sea salt. It would be sea salt. So any salt in this area is good salt that will take care of the iodine problem. So there you go. However, if you go farther east, on the other side of the Mississippi River, in Illinois and Indiana and Michigan and Ohio and Kentucky and Tennessee, there was no ocean right there. So of course they didn't have any iodine in them. They didn't have any salt for one thing, but they also didn't have any iodine in whatever salt they had. Yeah, so you guys are okay. You were fine, as long as you put salt on anything. The salt that you found wherever you found it was good, was iodized salt. But nobody realized this until 1924. As a fetus is developing, if the thyroid hormones are not high enough, they will. I'm going the wrong direction. There you go. There's the baby. Okay. They will cause stunted growth, facial malformations, and reduction in brain size. And of course, this is a condition we refer to as cretinism. It's because they are hypothyroid. So what we have to do is, when a baby is born, one of the first things we do is check their thyroid functioning. As long as their thyroid functioning is fine, we know that their brain development is okay. If we can start these kids on T3 and T4, because they're hypothyroid, we need to increase their thyroid level, their thyroid functioning. If we can do that, then they will develop normally. They will develop normally. In the old days, we didn't understand what was going on. So there were a lot of children that were suffering from a form of intellectual deficit due to the fact that their thyroids weren't functioning properly and their brains didn't develop normally. And this is a problem that we refer to as cretinism. We still refer to it as cretinism, but it's relatively rare because we check every baby. We check all the babies. We don't want this form of intellectual deficit to take place. Whew. Okay. Okay. What makes males males and girls and females females is the fact that they have different gonads. Males have testicles and females have ovaries. The male gonads are the testes, of course. They're located in a sac beneath the penis. Each testis produces millions of sperm a day through Sertoli cells. In and among the Sertoli cells are Leydig cells, which secrete testosterone. These are the Sertoli cells. These big round ones are the Sertoli cells, and these little bitty guys are the Leydig cells, and they produce testosterone. For some reason, our sperm counts are decreasing. They've been cut in half in the last 50 years, and we're not exactly sure what's going on. We don't have any idea. We don't know if it's pollution. We don't know if people are wearing the wrong style of underwear. We have no clue what's going on. It's really bizarre. After World War II, a lot of babies were produced. That was the time of the baby boom. And of course, sperm counts haven't been always that accurate, but before World War II, the sperm counts were relatively high. After World War II, they were relatively high, and now they are half of what they were before. When I first started working in the laboratory, the normal sperm count was between 240 to 300 million per mil. Okay. Now it's about 120 million per mil to 240 million per mil. That's normal. So what was abnormally low before is now the normal. Is it because we don't need that many sperm? No. In the future, we may have problems reproducing because of the low sperm counts that we're seeing. And we have no idea what's going on. We know that there are select things that do reduce your sperm count, and one of them is marijuana. But there can't be that many people smoking that much pot in order to create a low not testosterone, but a sperm count. We're not exactly sure what's going on. It's driving people crazy. They have no clue what's going on, and they don't know what's going to happen in the future. We may have to do artificial insemination to impregnate anybody in the future. We may have to concentrate sperm cells in the future just to get women pregnant, which is kind of shocking.
The artificial insemination, what's the oldest you could be to have that done?
Oh, you mean as far as a female's concerned?
Yeah.
You know, they can, as long as a woman is ovulating.
Someone that could care for a child at that age.
Well, I don't, you know, that's
Yeah.
not really what they're looking at.
So it
As
really
long as they're
doesn't matter.
ovulating, they can get pregnant. I've known women that continued their menstrual cycle into their 70s. So potentially they could get pregnant. Whether they could carry the pregnancy to term is another question. You know, things do degenerate in time, so the probability of carrying a child at that age it's possible, but you know, how likely is it going to happen?
Yeah, I once, maybe 2 years back or so, I heard a lady that born babies at 60.
Mm-hmm. Yeah, for her daughter, if I'm not mistaken, her daughter had a problem, so she bore her daughter's child. They implanted it in the grandmother. Yeah, in the grandmother. And then she gave birth to the egg and fertilized egg of the mother. Weird. It really all depends on the health of the mother. Okay. As long as she's healthy, then probably you're okay. I mean, there are things that take place, that there is a reason for menopause. It's because this body can no longer sustain a pregnancy. So it would be a tragedy for this individual to get pregnant and then lose the pregnancy. So usually, you know, as a woman ages, and sometimes this happens to them. I mean, women will go through menopause in their 30s. It's not all that common. I mean, normally it happens in their 40s, late 40s and early 50s. But like I said, I knew a lady that was still having periods in her 70s. She was a hoot. She was so funny. She was a rancher from Oklahoma. And she only came in like twice a year. We only saw her a couple times a year. And she'd come in and she'd say, well, you know, it's time for my hoo-hoo inspection, you know, that kind of thing. She talked about her vaginal area as her hoo-hoo. She was a hoot. And the doctor, of course, was shocked that he had never inspected, you know, had never given her a physical. And she came in and she was having periods with no menopausal symptoms whatsoever. It's really kind of strange. And she didn't know any better, you know. Back in the old days, women didn't talk about these things. Testosterone and other androgens are regulated by luteinizing hormone from the pituitary gland. We remember luteinizing hormone as the one causing a woman to have her menstrual cycle. Luteinizing hormone is controlled by the release of gonadotropin, releasing hormone from the hypothalamus. So once again, all of this stuff is controlled by the hypothalamus. And that's boys. Boys, Leydig cells and Sertoli cells. Sertoli cells produce the sperm, and Leydig cells produce the testosterone, and that's what allows the male to reproduce. Female reproductive area is a little bit more complex than the male is. The male's reproductive area. The female gonads are their ovaries, of course. They're located above the vagina at the very bottom of the abdominal cavity. There are 2 ovaries, one on each side of the uterus. The ovaries produce progestins and estrogens. They had a case of identical triplets, which is it's extremely rare. I mean, usually if you have the vast majority of twins that are born are fraternal twins, because you get an egg from one ovary and an egg from the other ovary. They get impregnated, and so the mother gives birth to 2 children at the same time, but they're brother and sister, or they're brother and brother, or sister and sister, but they're not identical. The splitting of the egg is not that common. It's only about 30% of all twins born are that way. But having an ova split in 3 parts and produce 3 different children is extremely rare. We hardly ever see that. But there have been cases of identical triplets. Very, very odd. Okay, so what are we talking about? Okay. The most important estrogen is estradiol. Primary progestin is progesterone. Estrogens trigger the production of progestin receptors in the brain. Hence, with puberty, progestin sensitivity ushers the menstrual cycle after estrogen is secreted from the ovaries. And of course, this is what causes women to go through puberty. All 3 sex hormones, androgens, estrogens, and progestins, have a similar chemical structure. They are 4 interconnected carbon rings. The sex hormones, along with the adrenal steroid, are derived from cholesterol. So if you reduce your cholesterol level a great deal, and that may have something to do with what's going on as far as sperm counts are concerned, if you reduce your cholesterol too much, then you're not going to produce sex hormones. Estrogens are synthesized from androgens, and androgens are synthesized from progestins. Both males and females have the same sex hormones, only, of course, in different proportions. So the reality is we all have the same juice in our bodies. We just have it at a different level, as odd as that seems. Okay. All we're talking about the sex hormones. Unlike most brain structures which are paired, there is only one pineal gland. It's right behind your eyes. Lays on top of the brain stem. Pineal gland produces the amine hormone melatonin and tells you when to go to sleep. Melatonin receptors are not only metabotropic, but they are slow. They are so slow. They activate G proteins, of course, because they're metabotropic. So if you try to regulate your sleep pattern, it's really hard to do it in a short period of time. Usually takes days to regulate your sleep pattern, to change your sleep pattern. If you've ever wandered east to the East Coast, or wandered to another country, Japan or wherever, been to Asia, regulating your sleep after you travel gets to be kind of difficult. They used to tell you that if you took melatonin, that you wouldn't have as much, your jet lag wouldn't be as bad. But the reality is it takes forever to get the melatonin to work. So it still takes a number of days before everything is okay. Where were we stationed? I went to visit my son. I think we're in Mississippi, and I flew out to Los Angeles. My son was working in a bar, and he had the most god-awful hours you can possibly imagine. I mean, he went to work at like 10 o'clock and got off at 6 o'clock the next morning. It was horrible. So I got on a plane and flew out there. Of course, my brain is 2 hours behind anyway. No, we were on Eastern time. I was 3 hours behind him. So we got in at midnight, my time, and it was 9 o'clock his time. So I immediately went out to the bar to see him, And I just about fell asleep standing there. I mean, it was that bad. And he didn't get off until 6 o'clock the next morning. Well, as far as my brain was concerned, it was 9 o'clock the next morning when he got off work. It was just horrible. I just about collapsed right there in the bar. I found out that I can't hang. But I just flown for like ever. Well, 3 hours. I was 3 hours behind, or 3 hours ahead of it. Since melatonin activates metabotropic receptors, reaction to it is extremely slow. Melatonin regulates your circadian rhythm and your reaction to light and dark. And of course, this can get confusing. This is why if we are in artificial light for an extended length of time, this is what happened to us when we were in the cave. You lose about an hour every 24 hours. So your brain is telling you, your brain's trying to regulate your circadian rhythm. So if you're locked up in a cave for an extended length of time, like we were in there for about a week. We had our watches, but it was really kind of strange. Nobody's watch was working quite right. My daughter has this, and of course she wasn't there, but my daughter has this thing. There's some electrical charge going on through her body, and her watches never have the right time on, ever. They're an hour behind, or an hour ahead, or an hour, or 15 minutes this side, or 15 minutes that side. There's something going on with her. If she wears a watch that has a battery in it, it will accelerate for some reason, and it makes the watch run fast. It's just the strangest thing in the world. So she can't wear a watch on her wrist. If she does, it screws it up. And of course, her Fitbit, she wears a Fitbit on her wrist, and by golly, that thing's reading like 15,000 steps, at 8 o'clock in the morning. It's just the most bizarre thing in the whole wide world. There's something going on as far as her electric. I think she's an alien. I think it's her mother. She was an alien. There was something wrong with that lady. I'm sure there was something going on with her. Anyway, light and dark, of course. So we were losing about an hour, and by the time we got out of that cave, which was about a week later, 8 days later, nobody's watch was accurate. We were all thinking it was later than it was. We had lost an hour every day. So by the time we got out of there, we were like 7 hours behind. It was just the most bizarre thing in the world. And of course, you get into an argument with somebody as to what time it was, because nobody's watches were working correctly, and everybody was losing an hour, but one guy was losing an hour and 15 minutes, and another person was losing 45 minutes. So, I mean, there was all this argument going on. They had to pull us out of there just to keep us from killing each other, because nobody could agree on what time it was. Melatonin can be used to move the sleep cycle up in the night. We had one individual that had a nervous breakdown. Because of it. He had a nervous breakdown. Because he couldn't tell what time it was. As strange as that is. And this is one of the reasons why, strange things happen in prisons too, but usually at least they let you see the sunshine, and we weren't allowed out for like 7 days. And they knew that something was going to happen. I think they were just trying to figure out how many of us they could knock off. Melatonin can be used to move the sleep cycle in the night, but because it has a metabotropic receptor, it only works over time. And of course, this is the problem I was just talking about. Your pancreas is extremely important. This is a really important part of your body. Once upon a time, we couldn't transplant pancreas, but now we can. Of course, we have that capability. Your pancreas has a lot of acid in it, and for that reason, the pancreas is very delicate. It's very fragile, so it's really hard to operate on. It's very hard to transplant. It's really hard to maintain. If anything ever happens to your pancreas, if you get pancreatic cancer, it's like 85% fatal. There's not a whole lot we can do. If anything blocks in your pancreas, it's just about over with. We had a guy that, I was stationed in Lubbock, Texas, and we had a guy with an abscess on his pancreas. And of course, it's like 99.9% fatal. So we sent him to Wilfred Hall to die. We sent him to Wilfred Hall to die, and normally he should have died. But for some reason he got this wild hair up one of his body parts. I'm not exactly sure where it was, but he started running. And this guy, he decided he was going to run himself to death. So he started running, and he was running, 30, 40 miles a day. This guy was going nuts. And something reversed itself, he repaired himself. He repaired himself. It was the oddest thing in the world. Of course, not everybody has the wherewithal to run 30 or 40 miles a day. But he came back. He actually came back. We didn't expect to ever see him again. We thought he was... Every time we sent somebody to Wilfred Hall, they died. We sent the people there to die. Anyway, he came back, and he was fine, but he still ran like crazy. And of course, this is Lubbock, Texas, and it's hot as here in the summertime. And here this guy is stripped out to his running shorts, and he's just jogging all over the place. He's got the nastiest looking abscess. I mean, he's got this horrible scar on his gut. Looked like it, went all the way back to his backbone. It was horrible. But of course, it's so hot outside, you couldn't wear clothes. Anyway, really strange. Anyway, pancreas, one of those areas, one of those things that you really can't live without. If you're working in the emergency room and somebody's been shot or somebody's been in a car accident and they have a lacerated pancreas, not a whole lot you can do. Remember, it's very acidic. It produces the stomach acids, and for that reason, if anything happens to your pancreas, it's just about all over with it. So you've got to, there's not a whole lot the doctors can do. The pancreas serves two main functions. It produces digestive enzymes, which are extremely acidic. And as an endocrine gland, it secretes insulin and glucagon, so it controls all the food that goes into your body, your metabolism. The endocrine gland portions of the pancreas is a series of specialized cells called the islets of Langerhans, and that's the part that controls insulin and your glucose functioning. Both glucagon and insulin affect glucose utilization by the body's cells. Peptide hormone insulin is produced in beta cells within the islets of Langerhans, while the glucagon is produced in alpha cells in the islets. So you have alpha cells and beta cells. The beta cells produce insulin, and the alpha cells produce glucagon. When glucose rises to a select point, the insulin is released into the bloodstream, of course. The insulin induces the cells to use more glucose and reduces the amount of glucose being released by the liver, lowering the blood sugar level. And of course, this is what diabetes is. If your insulin doesn't function properly, of course, your body cannot utilize glucose. It can't feed itself, so the person loses body fat. The first thing that you notice is the person just, all their body fat goes away. Of course, it makes somebody that's been overweight, it makes them really, really happy that all this body fat's going away. But what's happening is their body is trying to utilize whatever energy it can possibly get in order to maintain itself. But the insulin isn't functioning properly, so they'll lose weight right down to nothing. Of course, eventually they go into the doctor draws glucose on them, and finds out that the glucose in their body is really, really high. And the reason it's high is because their body's not utilizing it. So they will, of course, then they will give them insulin. Their body's not producing insulin, and this is the problem. The type 2 diabetes, on the other hand, their body cannot utilize insulin. It doesn't recognize insulin. Their cells become insensitive to insulin. And that's type 2 diabetes. The result is the same. You got a really serious problem that you have to give them something superficial. You have to give them something artificial, either artificial insulin if their body's not producing insulin, or they have to give them metformin, which forces the body to utilize the insulin. It's a chemical that tells the body to utilize the insulin. Well, what it will probably happen with type 2 diabetes, really hard to maintain type 2 diabetes. Usually what happens if the person doesn't go on a relatively strict diet where their intake of sugar is reduced, they're going to have a lot of trouble. They're going to have a lot of problems, of course, and we see this all the time. Too much glucose in your system will cause circulation problems, and it forces the blood vessels to harden. And once they harden, if they break, of course, now we're not getting enough circulation to a select portion of your body. Usually it's the extremities that suffer first. Usually it's the feet that suffer first, so they lose toes, then they lose feet, then they lose legs. It's just not real happy. Circulation into the eyeball is reduced, and they can go blind, unfortunately. Anyway, that has to do with the pancreas. Glucagon serves the opposite purpose of insulin. When the pancreas detects a low blood sugar level, glucagon is released, and it induces the liver to release glycogen. There is a paracrine action between the alpha and the beta cells of the islets of Langerhans, so they're communicating with one another. The beta and alpha cells are communicating with one another. One has to do with not enough glucose in the system. The other has to do with releasing insulin so the glucose can be utilized. And that is the end of the hormone chapter. Sorry to give you a downer right there at the end. I apologize. This is the 6th week, and I'm on chapter 6. Okay, I know. Joe's in the back. He's ready to jump up and down, but that's okay. Control yourself, Joe. Control yourself. We'll be okay. I know. I've caught up with myself. I'm so happy. Okay. Evolution of the brain and behavior. We're going to talk about evolution. You don't have to really believe in evolution. It doesn't really make any difference. We're going to talk about how the human brain differentiated itself from other animals. Modern scientists see the study of change of life over the ages due to natural selection and sexual selection as beneficial to understanding humanity from more than just its current snapshot view. One of the problems is that we don't know what happened in the past. And it's hard for us to visualize what humans look like 1 million years ago, or 2 million years ago, or even 500,000 years ago. It's really difficult for us to see that. It's very difficult for us to understand that there have been humans with bigger brains than we have. Neanderthal man had a much larger brain than we have. So potentially we're not the smartest humans that have ever been on Earth. And that really pisses people off. Some people anyway. They like to think they have an ego. Their ego is wrapped up in talking about these things. This can be done through DNA analysis, where scientists compare the DNA of one species with another, and we can. We can look at chimpanzees. We can look at great apes. We can look at monkeys. We can look at lemurs, and we can compare us with them, our DNA with them. One of the interesting things about chimpanzees, if we look at chimpanzee DNA, it is very similar to human DNA. As a matter of fact, the difference is only 1.6% difference. Us and chimpanzees. Does that mean that we're like chimpanzees? Can we breed with chimpanzees? No, we can't, because we don't have the same number of chromosomes that they do. So our DNA doesn't look at all like their DNA. And I don't remember how many chromosomes they have. I think they have 52, and we have 46. So we couldn't put the two of us together. It just wouldn't work. The chromosomes wouldn't match up. There would be extra chromosomes as far as the chimpanzees were concerned. So it just wouldn't work. The reality is, this is really kind of interesting. We can look at all the different looking humans around the world, and we are almost identical to one another. It's really kind of odd. We can determine what your DNA, we can determine what your ancestry is by looking at your DNA. But we're only looking at very few structures. The reality is that somebody born in New Guinea and somebody born on the reservation here and my family born in Indiana, if we looked at all of our DNA, it would be almost the same. Despite the fact that I don't look like you guys do, and the people in New Guinea certainly don't look like either of us. We wear different clothes. They don't wear clothes at all, so that's kind of interesting. But we don't look, but our DNA is almost the same, as exciting as that is. So we're really close to each other. All humans are really, really close to each other. We're a brand new species, and there isn't that much variation in our DNA, not like the chimpanzees. If we look at chimpanzees and we look at chimpanzees from one side of the mountain and with chimpanzees on the other side of the mountain, the difference between their DNA is much greater, even though they live in the close proximity to one another. Their DNA is much, much more different than ours is as humans, no matter where we look at humans. And this is one of the reasons why we assume that humans started in one place and spread throughout the world. And that one place that they started was Africa. That's the assumption. Of course, we have our... everybody has an idea of where they came from, and very few people say, well, I came out of Africa. Didn't we all? Very few people actually say that. Usually there is a... I'm not going to say the word. I'm not going to use the word myth because it's not really true. Everybody's got a story as to where they came from. The Choctaw, I think they came out of a mound. I've been to that mound. I've seen that mound. It's really interesting. It's in Mississippi.
Around here, there were the Anasazi people. They were very small people.
Oh, they're short?
In the caves.
Short guys? Okay. Have we seen their skeletons? I don't know, but that's just...
We see their homes.
We have seen their homes. They're not very big. Okay.
And the place over here, Chaco Canyon.
Okay.
Yeah.
Okay. Their homes are relatively small.
Yeah.
If you go up north to Montana, they have caves where people used to live, and these things are really tiny. We haven't found any skeletons, but we've found pottery inside these things, and drawings on the walls. But they're too small for people today to get into. They refer to these people as the little people. And theoretically, they weren't very nice people. They were kind of mean. Anyway. I don't know. I have no idea. But all I can tell you that if we checked our DNA, your DNA and my DNA, that it would be almost identical, like 99% the same. Despite the fact that I'm 100% European. And my people came from like 3 different places. Well, 4 different places. Belgium, Germany, France, and England. 4 different places, and that's it. No checking out the chicks down in Italy. None of that was going on. Oh no. No checking out those good-looking ladies from Africa. That didn't happen at all. Just people from England, Germany, Belgium, and France. My God, what a boring group of people that I come from. Everybody's got the same color hair, everybody's got the same shaped nose. This is really kind of sad. There you go, 2 people that look alike. Scientists have been toying with the idea of evolution for a couple of centuries, and they were doing this before Charles Darwin and Alfred Russel Wallace published their findings in 1858. And the question is, who came up with this idea? They were very, very similar. This is Wallace, and that's Darwin up there. Of course, we blame Darwin for all this evolution and whatnot. Doesn't have anything to do with it. It really does. He's the guy that we read, but the reality is that Wallace was writing the same stuff. And there were a lot of people out there that were thinking about this. It had been going on for centuries that people were thinking about this, but Darwin's the first one that published But when he published, he had been thinking about, he'd been writing this thing for 30 years. So why in the world, if we were thinking about it for 200 years, didn't we talk about it? Why didn't anybody publish about it? What was going on to keep these people these scientists from saying anything about evolution? Do you have any idea? It's the church. And we're talking about all the churches. We're not just talking about the Catholic Church. We're also talking about the Protestant churches. They didn't want these ideas to come out either, because their idea was that God created Earth and He did it in 6 days. And that's all they wanted to talk about. They didn't want to talk about how humans have been around for millions of years and they evolved from chimpanzees. They didn't want to talk about that, because they thought that was blasphemy. I mean, it says right there in the Bible that man was created from God's image. Isn't that what it says? Isn't that what it says?
I think all our philosophies are different. How we came to be, like for us Navajos, we came out of Dinetra.
Right.
We came out from the worlds.
Right.
But
everybody's got their own
evidence-based
story.
or the researches, is that true? So
I don't know if we can research that to figure out if that's true or not.
And I think all ethnics, they have their own stories.
Everybody has their own stories, including Europeans that followed the church for 1,000 years, for 1,500 years, and the church wouldn't let them think about anything else. But we've got these scientists that are saying, wait a minute, this makes sense. If we look at these fossils, we can see that humans haven't always looked the way that we look today. And that's science. So you can follow science or believe science or think that Darwin is a sinner, a blasphemer. It really doesn't make any difference. That's what we're going to talk about right now. 1859, Darwin published on the origin of the species by means of natural selection. He made 3 main observations: that individuals of a given species are not identical. So if we look at, and I was watching those bluebirds. You've got mountain bluebirds here. I was watching a couple of bluebirds flying around, and one of them was probably female, the other was probably a male. But there was another male that came in, and that male didn't look like the first male at all. They were trying to steal my dog's food, but they didn't look at all alike. As a matter of fact, I've got a dog that came to my house yesterday, starving to death. Poor little thing was starving to death. Not little, it's about this tall. Anyway, so I fed it, of course, because I hate to see things starve to death. It's not the prettiest thing in the world. So I fed the dog, and now the dog's mine, obviously. I get the dog because I gave it food. But there were 2 other hound dogs that came around. They don't look anything like this dog. This dog's got black and white spots. It's got a tiny little head. It's kind of a big-bodied dog. Looks like a hunting dog. And those other 2 dogs are hunting dogs too, but they've got bigger heads, and they're brown. One of them's brown, and the other one is red. They don't look at all. Their tails look very similar. Anyway, individuals of a given species are not identical, obviously, from the dogs. Some of the variation is inheritable, of course. This dog had just given birth. As a matter of fact, her nugs, she still had nugs, teats that she was feeding her puppies with. There's still milk in her teats. I'm not exactly sure where the puppies are. Whether somebody killed the puppies, whether the puppies died. But this dog is just wandering all over out there, and you could see its ribs, and its abdomen was sucked in because it hadn't eaten for a long time. It had a rope around its neck that was really, really tight. I have no idea what's going on. Anyway, I took the rope off and fed the dog. Now the dog's mine, I guess. I inherited the dog. Because I'm a soft-hearted dumb shit, I guess. Not all offspring, of course, will survive, and possibly her offspring didn't survive. And possibly if I hadn't fed her, she would not have survived either. I'm assuming that since she was feeding puppies, that she's not fixed. So eventually I'm going to have to fix this dog. I almost called her a dad dog, but it's not her fault. I don't know what's going to happen. Yeah, me and Margaret, we got problems, don't we? We care more about animals than we care about our families. Darwin would later add a fourth corollary, that of sexual selection. Sexual selection states that each sex exerts selective pressures on the other in terms of both anatomical and behavioral features that favor reproductive success. Hence the strange anatomical features of some creatures. If we look at the female cardinal is brown. It's fairly camouflaged. But the male cardinal, you can see it coming from miles. It's the red spot flying toward you. This baboon, it's a mandrill. It only gets to breed if it has a colorful muzzle. The females sexually select the ones with the prettiest faces. The peacock, my God, I almost ran into one the other day. I was driving home from Albuquerque, and there was a peacock out on the road. And it wasn't the fact that I was going to hit him, I was going to run over his tail. I mean, his tail was as big as long as this table. How functional is that? He's got feathers that are this big. They're huge. And he's walking across the road. And he gets on the side of the road, but his tail's still out and halfway across the road. I almost ran across his tail. I don't know what would have happened if I'd run across his tail. But how functional is that? Why do peacocks have such long tails? Peahens are the ugliest looking things you ever saw. They look like guinea hens, is what they look like. But here we've got peacocks that are almost set themselves up for death. I mean, anything can catch them. They're dragging that tail along, running along. They can barely fly. They can't fly very well. Anyway, sexual selection. So do we do the same thing as humans?
Yeah.
We do?
Yeah.
We sexually select for select things?
Yeah.
Large chests on women so that they're hardly functional.
We get
They barely
picky.
stand up.
They
carry around these
all over the place. I mean, that's why I walked into Ultra the other day with my wife, and I was just amazed by like how many women were walking around and how much they're willing to spend just to have a pretty face, you know, or have
Right.
something to cover their face. And I don't know. I had to sit in there just walking around like, wow, and just looking at the prices of all these things.
Right.
$350 like
Sure.
hair dryers. And I'm freaking out about this.
That's very important.
And just the beauty products that come along with it, and just how much we as humans value, you know, to have,
Right.
I don't know, just to look good externally. I don't know. I was just kind of just thinking about all these things on a different level. I was like, wow.
In Japan, women have tiny little mouths. Men want their women to have tiny little mouths. In Europe, especially in some sections of Europe, they want their women to have the biggest breasts they can possibly have. And these things are enormous. They're barely functional. It's not like they need to feed, 15 children from all this milk that they're producing. They're just sexually select for these large breasts. In China, they don't. As a matter of fact, they think our European women look like cows, and they refer to them as cows because they have these huge udders, these huge chests. Sexual selection. Some people want this, some people want that. It's really kind of interesting. And we really do, you're right, we spend millions and millions of dollars on these things. But of course...
That's what I was going to mention is that too. And then the elongation. Some tribes
exactly.
do that.
Exactly.
Put rings. How many rings they can put around their neck.
Exactly.
It's crazy.
And I've got a picture of it in just a second. Sexual selection. Do we use sexual selection? Sure. If we want our women to have... How functional is this? Can these women actually eat? This is a plate on their bottom lip. Can they actually eat? How about the Chinese wanted their women to have really tiny feet, so they wrapped their feet in, and what they did, they actually they formed the bones so that they would curve underneath the feet, so they'd be smaller. This is what it looks like when they stood there. They could barely walk because they had no platform. I got size 12 feet. I'm only 5'6", and I got size 12 feet. They're like boats. They're like skis. I can ski along. I don't have to worry about it. But these women had like no feet whatsoever. How horrible is that? They did it for two reasons. One, they found small feet attractive, but the other thing is that they would maintain their hymens for an extended length of time because they took such tiny little steps. They couldn't ride on horses. That's why the story of Mulan is such an odd story, because not only did Mulan not have feet that looked like this, but she also rode horses, which meant that no man would marry her because she didn't have a hymen. As confusing as all that is. The flatheads. They actually put a board on their children's heads, and that's what it looks like. This is a picture from Lewis and Clark when they ran into the flatheads. This is how they formed the child's head. It wasn't just up in Montana and Idaho, that area. It was also down in South America. They would, I have a picture of this, and I wish I had brought my, when I went down to South America, they showed these skulls from individuals, Inca and the Moche and all these different groups. They formed different structures on their heads by putting things on their, wrapping their heads in select ways. They had one skull that looked like a heart. It was heart-shaped. They put a crease right down the middle of this kid's head so that the two parts stuck. I mean, it was just the oddest thing you've ever seen. But, they found that attractive. And of course, flatheads. If you didn't have a flathead, nobody wanted to have anything to do with you. You had to have a sloping forehead. Here's something that women used to do to themselves in the 18th and 19th centuries. They wanted to have the smallest waist possible. I'm not exactly sure why. What they were doing they were displacing their rib cage. They were pushing their rib cage up. And normally your rib cage comes right down onto your pelvis, but these individuals were cinching themselves up and pushing their rib cages up. And it also pushed their breasts up at the same time. As attractive as that is. Scarification, that marks that select individual as a member of a select group in Africa. Scarification. Sexual selection as far as height is concerned. The guy on the right is a Cherokee, whose average height was taller than most white people. He's like 6 foot something. But that's the average height of the Cherokee. The other guy's a pygmy from Africa. Another sexual selection. The tall people, they lived in rainforests in Africa, and the tall natives didn't survive in that environment. The little short guys did, and they were very good hunters in that environment. And of course, if you go up to buffalo hunting country, those Blackfeet and Crow and Sioux guys, they tend to be relatively tall, so that they can shoot down on the buffalo. I don't know, they used to tell me, shooting down on the buffalo. Why are you so tall? So I can shoot down on the buffalo. Yeah, right. Like buffalo were that short. When they rode the horses, they could shoot down on the buffalo. Anyway. Sexual selection, tattoos. Tattoos, another form of sexual selection. These ladies have elongated their earlobes to the point that they're laying on their chests. That's how long they are. This is what you can see their earlobes are really attractive. Okay. My brother-in-law did, or not my brother-in-law, my nephew did this. He put those things in his ears and he just kept stretching out his earlobe and stretching out his earlobe. And then finally he decided, I don't want to have an earlobe that looks like there's something wrong with me. So he just took it out and it grew back together and it formed an earlobe. I mean, the hole filled in and everything. It's just the oddest thing. But that kid is tattooed all the way, every inch of his body is tattooed all the way up to his chin and all the way down to his feet. I have no idea whether his pubic region is tattooed. I've never seen that part, not since he started getting a tattoo anyway. Here are the ladies with the elongated necks. They also have wear braces on their ankles as well, but they're elongating their necks. And the way they do it is they put the rings on there and it's actually pushing down the clavicle. So it's not really stretching their neck, it's actually pushing down their shoulders, making their necks longer. As attractive as that is, of course, I have to have a woman with a long neck or I'm just kidding, my wife is not. In the Kalahari Desert, these are Dinka. And it has to do with how high you can jump. And what they will do, they will just start bouncing up and down until they're elevating 42, 50, 60 inches. And as you can see, they just keep bouncing up and down. The higher they can bounce, the more likely that the women will be attracted to them. As confusing as that is. Anyway, and that's in the Kalahari. You can see how skinny these guys are. Not very, they're tall and skinny, but they can jump really, really high. These guys are just north of the Kalahari Desert. They're in the Sahara Desert. And as you can see, they put on a lot of makeup, but that's not the deal. It's the fact that they can move their eyes independently. If they can move their eyes independently, they can attract a female because they can move their eyes independently in odd directions. As you can see, this guy, one eye is looking over that way and the other eye is looking down. Well, these other two guys aren't really moving their eyes. But that's the deal. I mean, that's their seductive capability is how well they can move their eyes. As much fun as these people are. Anyway, so do we use sexual selection? Of course we do. Of course we do. In basketball country, it's the basketball players get to have all the girlfriends. And if you don't play basketball, you don't have any girlfriends. Football country, it's football players get to have all the sex. And all the rest of us guys, we're just kind of SOL, as it were. Sexual selection. Once upon a time, it was hunters. The better hunter you were, the more likely that you were going to get to reproduce. Sexual selection. In the military, I don't know what it is in the military. It's a third baseman. They're looking for good. That's how I introduce my. Oh, I forgot. I got two more to go. I'm sorry. There you go. There you go. There's he and there's she. Ooh, I know. Sexual selection. That's what I'm looking for. I'm looking for metal on the face, not in the mouth, on the face. Wow, hot stuff.
That don't look too good at all.
I'm just sexually excited right now. I can't control myself. It's the red and orange and pink hair plus all the metal that person's got on their faces. Anyway, sexual selection. We use the oddest things. And I'm not exactly sure what it is now. What were beards on men. It seems like all men have some kind of facial hair. We need to stop right now. So I'll see you guys next time. Thanks for sticking out through all the ugly pictures.
Have a good day.
We'll see you later. Sexual. She's a chick too.
Yeah,
she's hot.
Very hot.
I can barely control myself.
There's like a guy like that in one of the pawn shops in Windbrook.
Oh, is that right?
Yeah.
Too much metal. Too many holes in their faces.
Kind of freaked me out when I first saw it. 'Cause his hair's like a goat, or head's like a goat, like sharp beard too.
Oh my
Kind
goodness
of freaked me out
gracious.
when I first saw it. I was like, oh my gosh. What am I looking at?
Somebody must be sexually attracted to that guy, otherwise he wouldn't do it, do you think?
Well, it's his pawn shop, so,
Yeah, there
and
you
his
go.
family runs it, so
Okay, he can do whatever he wants.
the wife must be crazy or something. Alright, Bruce.
We'll see you, Joe. What am I doing? Carrying this stuff across the way. Oh.